On the senior interviews, really often you will get questions about algorithms. And during last 10 years, I saw lots of interviews where really good devs failed because they couldn't solve algorithmic tasks. But if you know the core principles how to solve algorithms, then you can answer lots of questions. So even if you don't know how to solve specific algorithmic question, with these steps you have a much better chance of success. This video is a part of my middle to senior front-end bootcamp. This is why if you find it useful, check the link to the full bootcamp under the video. So here we're getting such question on the interview. Given an array of integers, return the indexes of the two numbers that add up to a given target. And especially a task like this you can really often get on a piece of paper. So step number 1 here is to understand a question. It is important to read the question at least several times to understand what is our goal. So let's read it again. Given an array of integers. Okay, we know we have an array and there are just integers inside. Return the indexes of two numbers, which basically means we must return an array of two indexes that add up to the given target. So additionally to array of indexes, we're getting a target. Let's say our target is 10, then we must find two numbers inside our array, and the sum of these two numbers must be 10. Then we take indexes of these two numbers and we solved our task. So step number 1, understanding the question. We already did that. What is step number 2? It is asking an interviewer about constraints. And this is an extremely important question because most developers jump right to the coding. And then they code a solution, they present it to the interviewer, and the interviewer will find flaws inside. Why is that? Because every single task can have constraints or no constraints, and then there are a lot of edge cases in these tasks. When you are asking about constraints, it is easier for you, because it is simpler to build some task when you have constraints. In our case, it is important to ask, for example, are we getting only positive numbers or also negative numbers? And if the answer would be we're getting only positive numbers, then we have a constraint. This is why the coding process for us will be much easier. Another important question is, what can we do if we don't find these two indexes? What should we return? You might get an answer like just return an empty array, and this is also important to remember. So step number 2, ask the interviewer about constraints. Step number 3, write some test cases. So you must write all possible cases that you see for this task without even starting to code. So let's first write a successful test case. Let's say we have an array with 1, 3, 7, 9, and 2. And our target would be here 11. This is our starting information. What will be an answer? So we're checking. We have 1 and 3. 1 plus 3 will be 4. It is not our target. Then 1 plus 7, 8, not our target. 1 plus 9, 10, not our target. 1 plus 2, also not our target. And we're doing the same with all of them. Like 3 plus 7, 10 doesn't work, 3 plus 9, 12 also doesn't work, 3 plus 2, 5 doesn't work, 7 plus 9, 16, it's not that, 9 plus 2, it is 11, it is our target. Which means here we must write 3 and 4, which are indexes of two elements that we found. This is our answer. Now let's look on another array, for example 1, 3, 7, 9, and 2. So it is the same array, but our target is 25. We already checked it, we won't get here for any combination 25. So let's say that the interviewer said that we must return null if we don't find our array with two indexes, because there is no result. What other test cases we can have? For example, we have an empty array, and the target whatever, like 25, our result will be also null, because there are no two elements inside. What if we have just a single element like 5 and target is 25? The result also will be null because we don't have two elements. And let's say the last one is 1 and 6 with target equals 7. In this case it works and we will get back an array with 0 and 1 because the indexes of the elements is 0 and 1. So here we wrote all possible test cases for our question. And it was step number 3. Now step number 4 is to find a brute force solution without writing a code. And it is extremely important to do that without writing a code because you will immediately see if your solution works or not. So basically you need to find an algorithm to solve it without writing a code. And two most important words here were brute force, which actually means we're not looking for an optimized solution, we're looking for the fastest solution, the first thought that you have in your head, how to solve this task. And basically when we planned our test cases, I think you already got an idea. We loop through our array and just tried to sum elements like 1 plus 3, 1 plus 7, 1 plus 9, 1 plus 2. Then we're doing exactly the same for the second element, for the third, and so on until the end of the array. Which essentially means we simply have a loop inside the loop where we sum our elements. And we're doing that until we're finding to index or until the end of our array. This would be basically a brute force solution which would work. And we found our algorithm even without writing any code. So step number 4 was finding a brute force solution without writing any code. Step number 5 is coding brute force solution. So here I put all our test cases in the main.js file and we will write our solution. Most importantly, here are some limitations just for us to improve our skills. We don't want to use browser and we don't want to check the code is working through the browser or compiler. Why is that? Because we must be sure that we can do it on the paper also, which actually means we must write code and we must check in our head that all variables are being changed correctly and it is working as intended. So here I created main.ts and let's code now our brute force solution. Most importantly, you should try to limit compiling your code and using browser in order to validate if it is correct. Because if on the interview you will get this task on a piece of paper, it is important that you can validate it in your head just by thinking about your variables. So let's try to code this task. I want to name our function find indexes by target. And here we know that we are getting an array of our numbers and the target. So let's type this correctly from the beginning. We're getting an array of numbers, so it's number array, and our target will be a number. And here is how we will use it. We will get here result by calling find indexes by target, and inside we will provide exactly the first case. It is 137, 9, 2, and our target is 11. And after this I want to console log the result. Obviously we don't want to look in browser first, we want to validate it ourselves. And we already discussed what the brute force solution is. We simply will have a loop inside the loop to go through all our elements. And actually if you didn't know, this technique is called two-pointer technique. Why is that? We have in our array 2 pointers, and both of them are on the first element at the beginning of the array. Now we still have the first pointer on the first element on 1, but then we're moving another pointer, and we're changing it to 3, then to 7, to 9, and to 2, every single time making our calculation with sum. Now we're moving our pointer to the second element, to 3, and then we're starting again to moving the second pointer. This is why it is called two-pointer technique, because on your array of data, most often you have 2 pointers and you're moving them when needed. This is why I typically name variables p1 and p2, because they are pointers. So here let's write a for loop where we're starting from p1, and it is our pointer, starting from 0, and we're going to the length of the array. And here we want to increase our p1. Now we can copy-paste exactly the same inside, but here we will have p2 smaller than num length, and we're increasing it. But most importantly here, we don't start p2 on 0, we don't start it with number 1, we're starting it with 3, because we don't want a sum 1 plus 1, we want a sum 1 plus 3, which actually means our p2 starts with p1 plus 1. So every single time when we're changing p1, we start p2 one element further. Now we can write our logic. We need to check if two elements that we are comparing equals target. So we can write here if our nums p1, this is our first element, like 1, plus nums p2, this is our second element, like 3, equals our target, then we want to return directly an array with p1 and p2. And in this case, p1 and p2 are indexes. This is why we're exactly getting what we want. So we successfully created our brute force solution. But we are not finished with this step. Why that? We didn't validate that it is a correct solution. We could just call it in browser, but this is wrong. We need to do it in our head, so we can also code it without browser on a piece of paper. So let's start this out. I really like to write with comments in every single line the value that we have. In our case, if we are talking about our first array, the starting value will be 1, and in here we're starting with 3. Now we're checking 1 plus 3 equals target, which is 11, no, then we don't do anything and we're going to the next loop. Now we're changing our 3 to 7, we're checking 1 plus 7 does not equal, we're going to the next loop, we're checking 1 plus 9, again doesn't work, 1 plus 2 also doesn't work. After this we increase our p1, it is not 1 anymore, it is 3. What we are doing with our p2, it is p1 plus 1, so we are starting here with 7. Now we are checking 3 plus 7 does not equal 11, we are not doing anything. Now we increase 7 to 9. 3 plus 9 does not equal 11, it is 12, so doesn't work either. And now we have 3 plus 2, it is 5, we are not going to this if condition. Now we are changing our 3 to 7, and here we are starting from the next element, which will be 9. 7 plus 9 doesn't work for us, we are not doing anything. 7 plus 2 will be 9, also doesn't work for us. Now we are changing our element to 9, and we are starting to the next element, it is 2. 9 plus 2 will be exactly 11, we are going to this if, and we are returning our value. And here we are returning indexes, which will be exactly 3 and 4. This is our answer. So this is what you want to do in order to validate your solution. And now you need to go through every single test case that you wrote and check if your code is correct. For example, here, you basically understand that this code won't work for any elements because we will never hit the target 25, but we must return null back. Are we doing it in our code? Not really. It means that we found an edge case that we didn't cover. This is why now in our code we must return null. Basically, after these two loops, we can just write return null. And if in these two loops we didn't find our elements, then we're returning null. So we're covering this case. Exactly the same logic will apply here. If both loops are empty, we're returning null. If we have just a single element, then it will also return null. And with 1, 6, it will work and return 0 and 1 index. We successfully tested all our cases and it must work. As you can see in browser, we got back 3 and 4, which is exactly a correct answer for our array of numbers. Our step number 6 will be to analyze time and complexity of our solution. And essentially, when we're writing algorithms, it is important to make your solution as performant as possible. It is not enough to just solve it, you must solve it efficiently. And just to be realistic here, solving algorithms on the interview is not fully related to your everyday job. Really often you want to make your code more readable and you don't care that much about complexity of your algorithm because the amount of elements is not that big. But when we're writing algorithms on the interview, we must analyze the time and complexity of our solution. So what do we have here? We have a nested loop. We have 4 inside 4. And the outer loop with p1 will for sure go through all elements because we have here num's length. So it will make an iteration. What does this n means? N is the amount of elements in the array. So when your array is bigger, n is also bigger. The inner loop does exactly the same, it goes through n iterations. Essentially here it is n minus 1 because we're starting with p1 plus 1 and we're going to smaller than num length, but actually this is not that important, we can consider it a complexity of n. So the longer your array is, the bigger amount of iterations will be. So here we can say that the time complexity of our algorithm is O(n squared). What does it mean? It basically means that we're looping through our array n multiply n, and this is quite a bad and not performant solution. But obviously here you can say we could have a best case scenario where we're finding the element right away. Sure, it is possible, but we're always thinking about worst case scenario when we're talking about complexity. The second is space complexity, how much space our algorithm takes. And actually our algorithm here is really easy, because we have just two variables, p1 and p2, and these are just static variables which we're overriding, so they never become bigger like an array. So here the space complexity will be O1, and this is really awesome. It means it doesn't really matter how huge our array is, the space complexity doesn't get bigger. So this was step number 6, where we checked space and time complexity. And the last one, step number 7, is coding the performance solution. And here is a huge hint for you. When you typically want to optimize your solution, like for example here we have a problem with time, because it is n squared, you need to increase the space. It doesn't really work in any other way. You can rarely improve your time complexity without increasing your space complexity. And here I really suggest you to pause a video and try to implement a performance solution yourself. In this case you will better improve your skills. So how we can implement the performance solution here? And my idea would be to not do the second loop, because basically this is our problem. If we would loop just one through our array, then our complexity will be O(n), and this is okay. But having two loops is always not performance solution. This is why we must build our solution somehow around just a single array. And as I already said, another hint is to use space here, which actually means we must store data in some way, even if we need to allocate more memory for that, but we need to have just a single loop. This is why I want to store here a mapping where we will have references between indexes. So first of all, I want to create a variable mapping, and it will be an object with key, which will be a number, and its value will also be a number. And by default, it will be an empty object. Now we want just a single loop, so I will copy paste this p1, we don't need p2, and we're looping from the 0th element to num length. And first of all, what I want to get here is current mapping index. So let's create a variable current mapping index, where from our mapping, we're trying to read a key nums p1. So again, what is p1? This is our index, like 0, 1, 2. Nums p1 is a value. In our case, when we're talking about this array, nums p1 in this case will be 1, which actually means we're reading what is there as a value where our key is 1. And here we have two cases. If we're talking about our first element, then our object is completely empty and we don't get an element, which actually means current mapping index in this case is undefined. So we can check if current mapping index is bigger than 0, then we want to do something. In other case, we know we didn't find this element. So if we did not find an element, we want to write it inside. So inside mapping, the value that I want to write inside will be target minus nums p1 equals p1. So this is quite a difficult construction. What is our target? In our case, it's 11. Nums p1, we already know it is 1, which means we're writing as a key 11 minus 1 and it is 10. So inside our mapping, we're storing now 10. And as a value, we have p1, which is our index. Basically, it allows us to store the reference to the second element that we're trying to find without having an additional loop. because now inside our object we know that we're storing 10 as a value and an index will be 0, so it gives us all information that we need to know what element we're looking for. We're looking for 10 and what was an index of the element that fits us. And basically when we have 11, we want to have 1 plus 10. And as we store here the index of 1 and we know the index of the element that we're checking with the value 10, then we will have both indexes here. But let's first code the solution fully and then go through steps. So here we covered our else case, but what if we found such element? Then we want just to return this element, so it will be current mapping index, comma, p1. So if we're talking about the case that I just showed you, that we wrote there 10 and an index is 0, now we're going here and let's say that our current mapping index is bigger than 0. So we found exactly this pair, like 10 and 0. So what we're doing here, we're returning current mapping index. It's a value. So this is our first index, 0, we're putting it here, and p1 is an index that we found. When we found an element by 10, it means this is exactly the index that we need, and we put here p1. This is how it works. As you can see in browser, we're still getting 3 and 4, and it is correct. The last thing that we forgot to do here is obviously return null. And now it is time to do again test cases to check if our solution is correct. So let's look on our initial array. We're going inside, our mapping is an empty object. Here we start with p1, which is 0, and here we're talking about number 1. We're trying to find it inside an array by index, and we found here undefined. This is why we're going to this else, and we're writing inside target, so 11 minus our num p1. It is 1, so we're writing here 10, and the value will be 0. Now we're coming to the second element. Our second element will be 3, and now here we're checking. Do we have a mapping of 3? No, it is undefined. Then here what we're doing, we're writing 11 minus 3, it will be 8, and as a value the index will be 1. Now we continue with our check, it is 7. We're checking, do we have 7 as a key? No, we don't, it is undefined. We're going here, and we're creating here a target, 11 minus 7, it is 4, and the index of the element will be 2. We continue here again, it is 9, we don't have 9, we're going to else, and we're writing here 11 minus 9, 2, and the value will be 3. And now we continue and it is 2, we're checking current mapping index, it is not undefined, we see that here we have a key 2, so this is this pair. So here as our current mapping index, we have 3, 3 is bigger than 0, we're going here and we're returning an array with first of all 3, it is our current mapping index, and then our p1 index, which will be 4. This is what we're giving back. So we successfully validated our performance solution. Obviously it is better to go through all cases to make sure that it is working for all of them. And now it is time to talk about time and complexity. As we have just a single loop here, the complexity will be O(n). And this is a normal complexity. It means when our array is bigger, the amount of iterations is also bigger. Updating the mapping inside our for loop is constant, so we can say that this is O1. So overall the complexity here will be O(n). But what about space complexity? We introduced here mapping, and this is our biggest change. In the worst case scenario, it will store n elements of the array inside, so it is O(n) complexity. Just to remind you, here our time was O(n) square and space O1. Now we can write that our time is O(n) and our space O(n). And this is the performance solution, which is much more efficient than previous approach. So let's sum up all the steps. They are crucial, and if you stick to them, you will be golden. Step number 1, understanding the question. Step number 2, asking about constraints. Step number 3, write some test cases. Step number 4, find the brute force solution without writing a code. Step number 5, code brute force solution. Step number 6, checking space and time complexity. Step number 7, coding a performance solution and rechecking time and space complexity. So this is the roadmap how to solve all algorithmic questions on the interview. And if you are serious about getting a senior job, check my middle to senior bootcamp where we solve lots of algorithm tasks and make sure that you are prepared to become a senior developer. The link is in the description.